The sampling distribution of the sample proportion example. Fully describe the sampling distribution first. This includes the mean or the center, the standard deviation of the proportion, and whether the curve is well approximated by a normal curve. After you've concluded a normal curve is appropriate, then you would proceed by creating a z-score and calculating the probability. If the normal curve is not appropriate, you would stop and state the normal approximation is not justified. Either n times p or n times q will be smaller than 10 in this situation, and you would report which violation occurred. So suppose that 14% of Americans are left-handed. Consider a random sample of 250 Americans. A, what does the sampling distribution for the proportion of left-handed Americans in samples of 250 per sample look like? Give a complete description. And then B, what is the probability that more than 15% of the sample is left-handed? So let's look at the solutions. The mean is mu sub p hat, which equals p, which is the 0.14, because 14% is the proportion of the population, all Americans, who are left-handed. The standard deviation of the proportion is sigma sub p hat, and that equals the square root of p times 1 minus p over n. So that's the square root of 0.14 times 1 minus 0.14, which is 0.86, divided by 250, which was the sample size. That calculates to 0.021945. Check conditions to be approximately normal or nearly normal. A random sample of Americans is selected and categorized as left-handed or not. N times P equals 250 times 0.14, which is 35, and 35 is at least 10. N times Q equals 250 times 0.86, which is 215, which is at least 10. So all the conditions are met to treat the sampling distribution, or think of the histogram of all p hat values like a normal curve. We say that p hat has a normal distribution with mean 0.14 and standard error 0.021945. B. The chance that p hat is greater than 0.15 is converted into the equivalent z-score question. Z equals p hat minus mu sub p hat divided by sigma sub p hat, which equals 0.15 minus 0.14 divided by 0.021945, which equals 0.46. What is the chance a randomly selected z-score is more than 0.46? Table Z gives 0.6772 as the chance a z-score is less than 0.46. So 1 minus 0.6772, which is 0.3228, is the chance a z-score is more than 0.46. The chance a random sample of 250 Americans will result in more than 15% being left-handed is 0.3228, or 32.28%. Note that this outcome would happen roughly in 1 out of 3 samples. 32.38% is really close to 33.33%, which would be exactly 1 in 3 samples. So this outcome would not be considered unlikely to observe if the true population proportion P is 0.14.